Hello everyone. Hello my dear students, future electrical engineers. So this is me again, Engineer Joski. Okay. This time we are going to discuss an alternator. We are done discussing the definitions, the parts and construction of alternator as well as the application. At this time, we are going to focus on how to solve different um, problems involving alternator. Okay, so this time, let's begin with the definition of alternator. So it is a generator that delivers an AC voltage to the load. So this is the life of electrical engineering, no? For 5 years of studying, we're going to tackle what is the load, what is the characteristic of the power source, as well as how to transmit the electrical generated electrical energy to the load. Okay, so this time we are going to focus on AC voltage generated by alternator. Okay, so AC voltage might be a single phase, or it might be a three phase voltage. So as we recall, the frequency of the uh, voltage produced in an alternator depends on the number of poles and the speed, as it rotates, as the rotor rotates. So F, where the frequency is equal to the number of poles multiplied by the speed of the rotor divided by 120. So the frequency is affected by the number of poles and the speed of the generator. Okay, so let's the frequency is in hertz, number of poles, and the speed of rotation and or revolution per minute, or RPM. So this is the unit of the N. Okay, so let's have an example. Example, a 36 pole alternator is operated at 200 RPM. So what frequency is generated? Okay, so we have the number of pole, we have the N, the speed of rotation. So substitute to the formula, F is equal to P and number 120. So therefore, 36 times 200 divided by 120. So we have the frequency of 60 hertz. Okay, so 60 hertz. So in this situation, the frequency is directly proportional to the number of pole and the speed of rotation n. Okay, now induce EMF per phase of an alternator. Okay, so induce EMF as it rotates, as the rotor rotates, the magnetic field also rotates, since the rotor contains the magnetic field or the field windings in alternator construction. Okay, as it rotates, it induces EMF. So this is per phase, since we assume that the generated EMF is in three phase. So this time, E is equal to 4.44 kp kd and F in flux per pole. Okay, so P. So this is derived. We are done discussing this one, where it came from. Okay, so where the 4.44 came from, and kp kd and F and the flux per pole. Okay? So let's remember that um, this is induced EMF per phase. Okay, so E is RMS voltage generated per phase. No? The unit is in volts. Frequency in hertz. Okay, and it's not speed anymore. Huh? It's not speed anymore, but it is the number of turn per phase. No, number of turns per phase. Then P, or the flux per pole, must be in Weber. Okay, so if Maxwell na siya, so the formula will be multiplied by times 10 to the power of negative 8. Remember that one. If the unit of the flux per pole is in line of flux or Maxwell. Kp is a pitch factor, okay, in decimal value or in a percentage unit, okay. And then Kd is the distribution factor, decimal value again. It is unitless, no? Unitless. And K is winding factor. So if ever you are going to use the second formula, so you are going to multiply, no? Multiply the Kp Kd, and that will become the winding factor. Okay. Okay, so let's proceed to the winding construction. Okay. So one coil, okay, so let's check. One coil is equal to 1 turn but has 2 wires. Okay. So here, let's check one coil. Okay, so this is the beginning. Okay. And here goes here, and this is the other end. This is the end. Okay. So let's check. Asa manigikan, no? Saan nagsimula yung 2 wires? Saan nagmula yon? So dito. This is one wire. This is another wire. Okay, so that is considered as 2 wires. Why? Because if ever we are going to draw the number of poles, no? Sample. Okay. Sorry for this one, ha? This is north. And this is south. Okay? So these poles, okay, north and south, cuts, okay, the magnetic field. The magnetic field produced by these poles, okay, is being cut by this wire and this wire. That is why it is considered as 2 wires. Okay, 2 wires. Here, one coil. Okay, so let's check. The wire goes here, okay, and it turns again. Yeah. Then here. Okay, this is the end. So let's check. If we are going to draw, simple na lang. Okay. Okay, so pasensya na, ha? Kasi buotan manggod. So this is north, this is south. As you can see, there are 2 wires that cuts the magnetic flux here, and the same also here. That is why there are 4 wires in 2 turns na 1 coil. Okay? So I hope you understand, no? I hope you understand. If the coil pitch is full pitch, the generated voltages in both sides of the coil are exactly in phase. Okay? So the same as what I draw here. So you have north and you have south. So in phase, so in phase ang imong output. Okay? If fractional pitch is used, the EMF in the 2 coils sides are out of phase, which reduces the EMF. Okay? So if ever fractional pitch siya, like for example, napingis ang imuhang wire sa imuhang pool, not exactly, not perpendicularly sila na in position, no? So there is a fractional, there is a reduced MF also that is being induced, no, by that magnetic pole. Okay? So meaning, ma-reduce po ng imong output. Okay? So correction for this is done by multiplying the voltage equation by Kp or the pitch factor. Okay? Pitch factor. So Kp, okay? So Kp here is equal to sine, okay, P to the power of degree, no? P degree divided by 2, or that is, ang P na to is equal to coil span in slots divided by slot per pole, multiplied by 180 degrees. Okay, like for example, we have here, how many slots are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 slots. Okay, so 8 slots. There are 8 slots. So your coil is inserted here, the first slot, and to the last slot. Okay? Now, this is the span of the coil in electrical degree, no? Span of the coil in electrical degree. Okay. What is the coil span in slots? So remember, there are 8 slots, but the span is, okay, this one. Do not start with this coil, this slot. Start with this one. 1, 2, 3, 4, 5, 6, 7. So meaning, the span of the coil, or the coil span in slots is 7. And there are 8 slots, so meaning, there are 7 over 8, no? Multiplied by 180 degrees. So that is your, this one, huh? That is span of the coil. 7 over 8 times 180 in this situation, no? In this situation. 7 over 8, okay, times 180 degrees. So that is your span of the coil in electrical degree, then divide it by 2, then take the sine of the 8, and that is the pitch factor. Okay? Unless it is given, no? Unless it is given that the span of the coil in electrical degree is 120 divided by 2, so sine 30. Okay? So you can have the answer. Okay? So that is the pitch factor, no? Pitch factor. Remember that one. Okay? Note, coil span is always rounded off to the smaller whole number. Remember this one, eh? Rounded off to the smaller number. Okay? So next is, okay, let's have example. Fractional pitch. When can we say that it is fractional pitch? Okay. Assume that this is the pole pitch. So let's count how many slots are there. All in all, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, there are 13. And according to this example, from this slot up to this slot, it is 180 degrees. So meaning, full pitch punta siya kung dili pa niya gibutang. But since it is reduced, it is transferred, no, smaller in length. So therefore, that is, let's count. Let's count this one, eh? How many slots are there? The span of the coil, no? Span of the coil. It is 1, 2, 3, 4, 5, 6, 7, 8. So 8. Okay? 8. But how many slots are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So meaning, we are going to solve this one. We have 11 in total, no? 11 slots. 11 slots to make it full pitch, no? 11 slots to make it full pitch. But how many slots are there, no? Since it is fractional pitch. So 1, 2, 3, 4, 5, 6, 7, 8. So meaning A, so P equals, so 8 divided by 11, multiply it by 180 degrees. So that is your P. Okay? That is your P. Now, if the coil span is exactly a whole number, remember exactly whole number, the coil pitch is called full pitch. But if the coil span is less than, then it is called fractional pitch. Never man siyang mudako, no? Never man siyang mudako or greater than 1. Okay, so if the coil span is less than the full pitch, then it is a fractional pitch. Okay? So note that when full pitch is equivalent to 180 degrees. Okay? So there 180 degrees. When several coils in group are connected in series, the total voltage generated by the group is not equal to the voltage per coil multiplied by the number of coils in the group. It is always less than because the coils are displaced from each other. So the factor by which the generated voltage equation must be multiplied by what is called distribution factor. Okay, so atong basahag balik. So since they are connected in series, that is not an assurance that the total voltage generated is equal to the voltage per coil multiplied by the number of coils in the group. For example, na kay 7 number of series conductors, and then each one of the coil is, for example, one coil generates 12 volts. Okay, that is not your assurance that the total voltage will be 7 times 12. No? Okay, so dili siya pwede. Dili na siya pwede. Not equal to 7 times 12. But, nga naman, it is because coils are displaced from each other. Okay? Displaced from each other. Wala man siya nagluon sa usa lang ka slot. Okay? It is placed in different slots. That is why, the output or the generated voltage is also vary. Okay? Now, that is your distribution factor, no? It depends on how it is distributed, no? The magnetic flux, no? How it is distributed in the winding. Okay. So this time, that is your distribution factor. Okay. So Kp, Kd is equal to sine n alpha divided by 2 and divided by all over n sine alpha divided 2. Where your alpha is equal to 180 degrees divided by slot per pole. And your n is slot per pole per piece. Okay? So that is the formula. Okay? So where Kd is distribution factor, decimal value, and N is number of slots per pole per phase, and alpha is number of electrical degrees between adjacent slots. Okay? So, let's have an example. Problem number 1. So, in problem number 1, a 6-pole, okay, 3-phase, Y-connected, 60 Hz alternator has what? 12 slots per pole. And it has a 4 conductors per slot. Okay? So it has a 4 conductor per slot. The winding is 5/6 pitch. So that means that is your P, no? The span of the coil. Span of the coil. So there are 0.025 Weber. So there's no problem with the flux since the unit is in Weber. Entering the armature from each north pole, and this flux is sinusoidally distributed along the air gap. Okay? So what is air gap? Ang air gap kato ng the space between your rotor and your armature core. The armature coils are all connected in series. First is determine the pitch factor. Okay? Second one is what? Distribution factor, and the third one is induced EMF per phase. Okay? So now, pitch factor. So it can be solved directly, no? Solved directly. So Kp, okay, so Kp is equal to, okay, sine P over 2. Okay? So now, what is your span of the coil? Span of the coil is, since it is given that 5/6 ang imong pitch, therefore, P is equal to, okay, 5/6 times 180. And therefore, that is how much? 150 degrees. Okay, so 150 degrees. And since you have that one, so substitute, we have, okay, sine 150 divide 2. Okay? So therefore, you have EP of sine 150 divide 2. So that is point. So sine 150 divide 2, that is 75 degree divided sine of 75 degree is 0.966. So Kp is unitless. Okay? So Kp. Okay? So as you have noticed, only 966 is delivered or contributed to the induced EMF. So there is a loss, instead of having one, for example, if you are going to convert that one into percentage, so you have 96.7% only, is developed, for the induced EMF. So we have a loss, Not a loss. Okay? Now, next is distribution factor. So, distribution factor is KD, no? KD is equal to, okay, so sine, okay, n alpha by 2, okay, and n sine alpha over 2, no? So, that is alpha. Okay? Where alpha, no? Where your alpha is here. Alpha is 180 divided by slot per pole. Okay, so 180 divided by slot per pole. So we have slot, we have 12 conductors, 12 slots per pole. Okay, so wala na, no? Wala na yung problema. Slot per pole naman siya. Okay, so directly substitute na nani. Na? Slot per pole, and then your n. So what is n? Ang imong n is slot per pole per piece, no? Okay? So that is 12. Okay, so slot per pole man daw. So n is equal to slot per pole divided by piece, which is 3. So that is 12 divide 3. Okay, so imong n is equal to slot per pole per piece. Okay, so this is equal to 12. So therefore, n is equal to 12 divide 3, which is equal to 4. That is your n. Okay, so next is how to solve for alpha. So your alpha is, okay, so that is alpha is equal to 180 divided by slot per pole. So 12, no? So that is 180 divided 12, that is 15. Okay, that is your alpha. Substitute, no? Substitute all the kuan. So, okay, so for the convenient of all, so you are going to substitute na lang. Kamo na lang substitute, ha? Okay, taas na kayo. So, pagitag suwatan, eh. So, your KD will be 0.958. Okay, 0.958. Okay, your KD, distribution factor. Okay, so that is your KD. Now, what is the induced EMF per phase? So let's remember that E per phase is equal to 4.44. Okay, that is KP, KD, and F flux. Okay, so to substitute 4.44. Okay, so KP na to is 0.96, no? And 0.966, no? So 4.44, 0.966 is 9 here. Please follow na lang. So 0.96, 966. Then here, KD is equal to 0.958. Okay? And then N, turns per phase. So now, sulbunon pa na to, no? Ang N na to is, we have 4 conductors per slot, no? And we have 12 conductors per pole. Remember, unsa ginang kuan, unsa gina siya ang ato ang N? That is torn per piece. Okay? So, sulbunon pa na to ang N. No? Stagnan sa ta. Wala pa lamang man. So, ang N na to is torn per piece. So, torn per piece. And we have N which is equal to, okay, 4 conductors. 4 conductors niya per what? Slot. And we have multiplied by, okay, so we have 12 slot per pole, no? Slot per pole. Next. So, cancel na niya ang slot. Sunod. Next is, we have, let's remember that one torn is how much? Wala man gimension dire. So, meaning, one torn na siya, no? One torn, onya, how many conductors in one torn? So, we have 2 conductors. No? So, one torn, 2 conductors. So, cancel na ni conductors. Now, sunod, how many poles are there? How many poles? So, there are 6. So, cancel na ni pole, no? Poles. Okay? 6 poles. Okay? So, we have cancel. So, we have N which is equal to 144 turns. Okay, now, the question is, mo na niya itong gamiton dire, dili. Okay? Dili. No, the answer is no. Ano man? This is the overall number of turns. But, our N here is turn per piece. No? So, let's remember, 3 pieces siya. So, meaning, ang atong N will be 144 divided by 3. Oh, equal to 48. Oh. So that is 48 turns per piece. No? Torn per piece. So 48 ato yung solution. So we have 48. Okay? 48, then sunod. F. So given 60 times 60. Next is flux. So 0.025. Or that is 25 milliweber. Okay, so solve that one. 4.44 times 0.966 times 0.958 times 48 times 60 times 0.025. You will come up with the induced MF per phase, which is equal to how much? $295. That is volts per piece. Okay? So that's it, no? Okay, so that is the answer, no? So 295.7. So check na lang sa inyo, ha? And then I will let you answer this one. Okay? Answer this one and submit it to the Google Classroom. Ha? Submit it to the Google Classroom. I will make a thread there, no? Para makasubmit mo dito. Okay, so that's all for this video. Thank you and God bless. No? Thank you for listening. Thank you for watching. And I hope you understand. No? So bear in mind, practice more and more what you have learned, no, in this topic so that your mind will be sharpened. No? Okay, so God bless future electrical engineers.